So last class we started one new chapter, chapter number 3, motion in a straight line. So in this chapter, the basic knowledge about what is motion. The example, the difference between displacement. The things we now we are using one new app that is a practically. Wait a minute. It is first we will discuss speed.
Objective to analyzing the motion of a particle in three-dimensional space. To understand speed.
A video voice, it is audible.
Sir, your screen is not visible, sir.
Any others?
Screen is visible, sir. Audio,
The screen is not
no,
visible,
sir.
the audio is not audible.
The screen is not.
1 minute, ma'am.
Speed by analyzing the
Now my screen is visible.
Yes, sir.
Yes, sir. Visible, sir.
the motion of a particle in three-dimensional space. Let a particle travel from point A to point B along the path shown in time interval t. distance traveled by the particle in time t is the length of the path AB. Average speed of the particle is defined as the total distance traveled per unit time. Hence, average speed of the particle is equal to length of path AB, that is s, divided by t. Average speed could be different for different time intervals. Instantaneous speed. Suppose the particle moves through a small distance, delta s, in time delta t. The average speed of the particle in time delta t is equal to delta s by delta t. We can choose the delta t to be as small as possible. As delta t tends to 0, the distance, delta s, also tends to 0. Nevertheless, the average speed, which is the ratio of delta s to delta t, tends to a finite number. In terms of calculus, this is nothing but the rate of change.
You can zoom it, ma. That only video portion alone. Try to zoom.
Of distance, ds by dt. This is called instantaneous speed. Hence, average speed for an infinitesimally short time interval at a point is nothing but the instantaneous speed at that point. Mathematically, instantaneous speed is equal to rate of change of distance at a given point. If the equation is multiplied by dt and integrated within the limits of a time interval, we get the distance traveled by the particle in that time interval. Let us draw the graph of distance versus time. Distance, s, is represented on the y-axis. The corresponding time is taken on the x-axis. Point P of s, t, on the graph indicates that the object has traveled a distance s in time t. Slope of the graph at any point on the graph is ds by dt, but ds by dt is instantaneous speed. Hence, the slope of distance versus time graph gives instantaneous speed. Let us draw the graph of instantaneous speed versus time. Instantaneous speed is taken on the y-axis, while its corresponding time is taken on the x-axis. Consider the area under this curve between two instants of time. From integral calculus, area under it is given by integral of v dt. This is nothing but the distance traveled by the object in the given time interval. Hence, area under speed-time graph gives the distance. Summary. Average speed of an object is defined as total distance traveled in unit time. Instantaneous speed of an object is defined as the rate of change of distance. Slope of the distance versus time graph gives instantaneous speed. Area under the speed-time graph gives distance.
Okay, ma. Kindly watch the video. Again, I will explain. Okay. Speed. So next one, velocity. After we'll discuss speed and velocity difference.
Objective: to understand velocity by analyzing the motion of a particle in three-dimensional space. Let us consider the origin O as our reference point. To understand velocity by analyzing the motion of a particle in three-dimensional space. Let us consider the origin O as our reference point. A particle starts moving from point A. Its initial position vector is OA bar. It travels to point B along the path shown in time interval t. So the final position vector of the particle is OB bar. The displacement of the particle, S bar, is given by the final position of the particle minus its initial position, that is, OB bar minus OA bar, which is equal to AB bar. Average velocity of the particle is defined as its total displacement by total time taken. Hence, average velocity of the particle is equal to AB bar, or S bar, divided by t. Average velocity of the particle depends on its final and initial positions only, and does not depend on the path it takes. So, if the particle were to cover a different path between A and B in the same duration of time t, its average velocity would remain the same. Now, let's assume that the particle changes its position by a small distance delta S bar in time delta t. The average velocity of the particle in time delta t is equal to delta S bar by delta t. We can choose delta t to be as small as possible. As delta t tends to 0, displacement delta S bar of the particle becomes tangential to its path. Though delta S and delta t tend to 0, the average velocity, which is the ratio of delta S and delta t, tends to a finite vector. In terms of vector calculus, this rate of change of displacement, ds bar by dt, is called instantaneous velocity. Hence, average velocity for an infinitesimally short time interval at a point is nothing but instantaneous velocity at that point. Mathematically, instantaneous velocity is equal to rate of change of displacement. Infinitesimally small displacement ds bar is also equal to an infinitesimally small change in the position vector dr bar. Hence, instantaneous velocity can also be defined as the rate of change of position. The magnitude of instantaneous velocity is equal to modulus of ds bar by dt. Modulus of ds bar is equal to the distance traveled by the particle ds in time dt, and ds by dt is instantaneous speed. Hence, the magnitude of instantaneous velocity is equal to instantaneous speed. If the equation is multiplied by dt and integrated within the limits of a time interval, we get the displacement of the particle in that time interval. Let us look at an example that illustrates the difference between average velocity and instantaneous velocity. A particle moves clockwise with constant speed along a circular path in the xy plane. The radius of the circular path is 7 meters, and the time period of revolution is 4 seconds. Let's calculate the average velocity of the particle in different time intervals, starting from its initial position A, x equals -7. Circumference of the circular path is 44 meters. The particle covers 44 meters in 4 seconds uniformly. Hence, instantaneous speed of the particle at any time is equal to 11 meters per second. The particle covers 4 quarters in 4 seconds. After 1 second, the particle is at B. Its displacement in 1 second is equal to AB bar, which is OB bar minus OA bar. AB bar is equal to 7J cap minus of -7I cap, which is equal to 7i cap plus 7j cap. Average velocity in 1 second is equal to 7i cap plus 7j cap divided by 1.
One minute, I will share my screen. Okay, listen. Speed. Distance divided by time. Speed formula, distance divided by time. Otherwise, the ratio of path of length to the time taken. The ratio of path of length to the time taken. So this is a formula for the distance. Speed. The next one, the uniform speed it is a non-uniform speed it is a uniform non-uniform next one average fourth one instantaneous. So up to that you can understand uniform non-uniform average. What is instantaneous? It is for you more confusion. Okay, no need to confuse. It is very simple only. I will tell you. Okay, instantaneous. So first of all, uniform speed. So I will mark 4 places. This is the A, this is B, C, and D. The distance 10 kilometer. This is also 10 kilometer. This is also 10 kilometers. The distance is equal, and the time to travel, the traveling time also it is equal, around 10 minutes. So every interval it is in 10 minutes. 10 kilometers, 10 minutes. Otherwise, 10 kilometers, 5 minutes, 5 minutes, 5 minutes. So it is a uniform speed. Because they didn't change the speed. Like a highway. Whenever you go for highway, the driver maximum they follow for the uniform speed. Around 100 means every area they can follow for 100. But non-uniform means it is some city side. Traffic it is there, we reduce the speed. There is no traffic, we can increase the speed. So everything it is different. Time also variable, distance also variable. That is the non-uniform speed. So another one, average. We want to take average. That is the D1, D2, D3 divided by T1, T2, T3. Average speed. So see here A to B. One distance it is, I can write D1. Again B to C. So another distance, that is a D2. C to D, that is D3. So time taken, T1 plus T2 plus T3. So this is a finding the average speed. Okay. It is easy for you. Instantaneous speed. That instantaneous speed, just imagine the bowler. Okay. The bowler, they are overwise, they are saying first ball 140 kilometer per hour, second ball 130, fourth ball 150, like that. How they are calculating in this speed? Maximum students very interested in cricket. After the class completion also, some students going to match. I know very well. How they are calculating?
By using machines, sir.
Sir,
Yeah.
the speed in air, sir.
Okay, very good. Listen, this is kilometer per hour. Kilometer per hour. But that cricket pitch, what is the distance? How many steps? Around 11, 12. How many steps, ma? Tell me, boys. Batsman to bowler in between distance.
Sir, 12 yards, sir. Sir,
12
22
yards.
yards. 22 yards, sir.
22. Okay, no need to confuse. We take some approximate. Listen. So A to B, approximately we'll take for other students also understanding purpose. It is around 10 meters. Okay, so I'm releasing the ball. So one person releasing the ball. Okay, now within the seconds we want to measure one particular seconds in this 100 meter 10 meters means we need no need to measure 10 meters. In between on I will take on the point. For example, this is B dash, this is A dash, this is 1 meter distance. In this 1 meter, how much time it is taking? Instantaneous, within the fraction of second we want to measure. In this 1 meter, I will convert into kilometers. Okay, that and all, it is a instantaneous. So in this process, instantaneous, again we'll discuss very detailed with using the differentiation formula. Integral calculation it is there, no? Differentiation calculation it is there, and the conversion also there. Kilometer to meter per seconds converted into kilometer per hour, kilometer per hour converted into meter per seconds, and a minute. In this conversion time, I will explain very detailed. Now we know about instantaneous means within the seconds, fraction of second, we should measure the speed. So that is the instantaneous. ds divided by dt. Instantaneous. Okay, next one, speed, whether this is vector or scalar. What type of quantity? Speed is a scalar quantity. So only magnitude, there is no direction. But velocity to have a direction and magnitude. So next track we will discuss velocity. So up to speed, if you have any doubt, you can ask. And one more thing, listen everyone. In your test paper, it is no. You are writing the paper and uploading to MS Team. Definitely in first 2 pages, you should write your name, class, subject, date. Class means class 11th, what Biomax, CS Max, like that. You mention the group also, date, whether this is weekly test or diagnostics. So what is the test, cumulative test, that and all you want to mention properly. That is the first page. Then you can start with the first question. 3 students paper, it is not visible, it is not opening. I will say the name. Kindly resend it to my number, WhatsApp number. 1 minute. Where is that? In case I mention your paper in option means this is the reason. Your paper, it is not opening. Otherwise, your that PDF image it is no, that image it is not clear. In case the page number also, some students page also they are not following properly. Page number 1, page number 10, 9, like that. The interchanges also I mention as a absent.
Sir,
Yes.
sir, I have sent to your WhatsApp, sir, but you have not seen it.
Just again send it, ma. I will check it.
Okay, sir.
Akash, Divyasri R. See the names in chat box, ma. Akash paper, it is in link. It is not supporting. Next one. Sriya. Yes. AR. 3 students paper. So I can send it to my number, WhatsApp. And below you can mention your name, class, subject, date, everything. Then only I can understand easily. Okay, this is class 11th paper, this is 12th paper, like that. Ma, give me reply, ma. 3 students. Say yes or no. Your paper I mention as absent. If you want mark, I can resend it to my number. Okay. Thank you. Next we will discuss velocity. So velocity V is equal to displacement by time. What is displacement? Very shortest distance between 2 places or 2 points. The SI unit of displacement, meter per seconds. Dimension formula, m power 0, L power 1, T power minus 1. Dimension formula. Next, this is vector or scalar. So this is the vector quantity. Next, the types: uniform, non-uniform, otherwise variable, non-variable also same only. Uniform, non-uniform. Next, average. Fourth one, instantaneous. Now we'll discuss one by one. Listen. Now I will take xy coordinate. In this xy coordinate, there is a 2 points. This is the A, this is B. But the path, this is the path. But what is displacement? The very shortest distance between 2 points. So this is the between 2 points, very shortest distance. So this is the O, A. This is OB. The formula OB minus OA divided by time. Otherwise, R2 minus R1 divided by T. This is R1, this is R2, this is position vector R. So finding the displacement, velocity. Uniform velocity means initial and final. Every second or every minute, the speed, it is equal. Non-uniform, it is variable. Average, we are taking the values, all the V1, V2, V3, like that. Next one, instantaneous. Instantaneous velocity also same like the speed. Instantaneous velocity, within the seconds, we want to measure the value and calculating the entire thing. So before that, now we'll discuss one small formula, that is a calculus integral method, integral and differentiation. Now we'll discuss differentiation. One minute, it is loading. one paper, there is no name. See here. In case your paper means, please tell me, ma. In my this is my papers are like that in WhatsApp. I will mark yours. See your handwriting. Okay, listen. Speed. Speed of a body is equal to the distance traveled by the body per unit time. So which is easy definition you can follow. Speed formula, the SI unit meter per seconds. Normally we are using kilometer per hour. 1 kilometer per hour, it is equal to 5 by 18 meter per seconds. Because 1 kilometer, it is equal to 1000 meter. 1 hour, it is equal to 3600 seconds. 60 into 60, 3600 seconds. So simplify that, you will get 5 by 18 meter per seconds. Okay, first one, next one, uniform speed. When a body covered equal distance in equal interval of time, that equal in this word is very, very important. And to give me some example. Next one, average speed. Average speed, total distance covered by total time taken. Total distance covered by total time taken. Now some special cases it is there. Kindly zoom yourself that particular area alone. Now I know the distance value S1, S2, S3. Time value T1, T2, T3. So finding the average speed, that is the S1 plus S2 plus S3 divided by S1 T1 plus T2 plus T3. This is the formula number 1. Second condition, I know only the speed and the time interval. I don't know the value of distance. See here, if a particle travels at a speed v1, v2, v3 for time interval t1, t2, t3, there is no distance, but I want to calculate average speed. How to calculate? It is also possible. Listen, S1 it is there, no? S1 means here position ma. So V1 equal to S1 divided by T1. So instead of S1, I can write V1 T1. See here, S1 purpose, I am writing V1 T1. S2 purpose, same for S2 also. S2 means what? V2 into T2. In this condition, I know only about speed and time interval. So based on in these two physical quantity, I can follow the average speed formula. Any doubt? Shall we go for next formula? First formula, average speed. There is no confusion. Second case, if a particle travels at speed v1, v2, v3 for a time interval t1, t2, t3, finding the average speed. Any doubt? Say yes or no, ma.
No, sir.
Okay. Third condition. In this time, I know only the distance and the speed. Time value, it is question mark. I don't know the time value, but again, I want to find the value of average speed. Formula, velocity v, speed v is equal to v1 equal to s1 divided by t1. Okay. Third case, v1 equal to s1 divided by t1. Then t1 equal to s1 divided by v1. In this value, this is equation number 2. In this t1 value, I am applying for equation number 1. t1, the value s1 divided by v1. t2, s2 divided by v2. t3, s3 divided by v3. Finding the average speed. So this is one more formula. 3 formulas completed. Next we go for fourth formula also. Actually, this is the first formula. It is enough for the NCERT. Average speed S1 plus S2 plus S3 divided by T1 plus T2 plus T3. It is enough. But now we are preparing for competitive exam, so that we want to know about maximum things. Okay. In this case, the position, the distance value S1, S2, S3, it is equal to X. That means what? S1 value also 10, S2 value also 10, S3 value also 10. Now 10 plus 10 plus 10 means 30 it is now. Now I mention as a X, 3X divided by X by V1 plus X by V2 plus X by V3. Do the cross multiple. Finally, you will get 3 V1 V2 V3 divided by V2 V3 plus V1 V3 plus V1 V2. Please take a notes, ma. Remainder things we will discuss next class. Okay. Today we'll complete up to speed. If you have any doubt, you can ask. Take a notes.